Hello everyone, this is Ahed from Logos Learning, and in this video I will be talking about rational exponents and how to work with them. So we have two rules to keep in mind. First rule, if we have base a to the power of 1 over n, so this is our exponent, it's a rational exponent because it is a fraction, then the denominator of the fraction becomes the index of the radical, and the base becomes the radicand, or whatever is inside the radical. Here n has to be a member of all natural numbers. Natural numbers are positive integers. So in order to evaluate these problems in the real number system we have two conditions. First, if n is an even number, which means it can be 2, 4, 6, so on, then a has to be bigger or equal to 0. If a, on the other hand, is smaller or equal to 0, then there will be no solution in real number systems. So let's take a few examples. If you have 4 to the power of 1/2, here n is an even number, 2, and a, our base, is a positive number. A positive integer is a natural number. So this is equivalent to saying the square root of 4. Can we evaluate the square root of 4? Yes. It is equal to 2. Another example, if you have 81 to the power of 1 over 4, same thing, n is even, and a is bigger than or equal to 0. Here, this is the fourth root of 81, which is equal to 3, and we have solutions in R. Now, if a is smaller than 0, a is negative, for example, negative 4. If we try to take the square root of negative 4, well, you can put it in a calculator, it's going to be an error. It doesn't work in real numbers. So no real solution. Now, if n is an odd number, so if n is 1, 3, 5, 7, and so on, then a can be any number. For instance, if you have negative 4 to the power of 1/3, I'm going to choose a hard number here. Now, you can take the cubic root. What's going on here? You can take the cubic root of negative 4. Another example, if you have the cubic root of negative 8, that's a better example, because we can have a nice solution for this one. You can take the cubic root of negative 8, which is equal to negative 2. So it would work. Now, the second rule is if you have base a to the power of m over n. So here in our exponent, the numerator is not 1, it is another number, m over n. Then this is the nth root of a over m, or a to the power m, or you can write it like this, the nth root of a, and this whole thing is to the power of m. We have to keep in mind here that m and n are both natural numbers. Now, let's apply these rules in order to get some practice. Write the radical form of the following expressions. So when I convert this from exponent form to radical form, 2 to the power of 1/3 is the cubic root of 2. Again, the denominator becomes the index, the base becomes the radicand, whatever is inside the radical. Same thing here, this is the square root, and we don't have to write a 2. Whenever there is nothing, it's implied. Square root of x. 6 to the power of 3 over 4. Here, this is the fourth root of 6 to the power of 3. And b to the power of negative 5 over 6. Here, we have to change the sign of the denominator of the exponent first by inverting the fraction. So this becomes 1 over b to the power of 5 over 6. So when we bring the b from the numerator to the denominator, we can change the sign of the exponent from positive or from negative to positive. Now, 1 over, we're going to evaluate this. 6th root, or sorry, not evaluate, change the form. The 6th root of b to the power of 5. And that is it. We converted all of these from radical form, from exponent form to radical form. Next question. Write these expressions using exponents. So we're going the opposite way here. What is the index on this radical? Since there's nothing, it's a 2. So this is 7 to the power of 1 over 2. Here, this is a square to the power of 1 over 5. We're not going to leave it like this. We're going to multiply these two together because we know from the last video that a to the power of m, what's going on? 1 minute guys, technical difficulties. 1 to the power of m to the power of n is equal to a to the power of m times n. So we're going to apply that here. We're going to multiply the 2 and then 1/5. We have a to the power of 2 over 5. Same thing for the third one. 2b squared thank you for your patience. 2b squared to the power of 1/3. So the power of 1/3 applies to both components of this one term. So this is the one term. So this is the equivalent to applying this rule. ab to the power of m is equal to a to the m times b to the m. So the exponent applies to both components of this one term. So this is equal to 2 to the power 1/3 times b squared to the power of 1/3. We're not done yet. This becomes 2 to the power 1/3 times b, and we're going to multiply these two exponents together, to the power of 2/3. Now in this next question, we're going to evaluate the expressions, and I'm going to talk to you guys about the power of parentheses, brackets. So if you have -9 to the power of 1/2, at first look you might think, this is an even exponent, even denominator, even n, and a is negative, so there's no solution. But this is not the case because the 1/2 applies only to the 9 because there's no bracket between that keep the 9 and the negative together. So this is negative square root of 9, which is equal to -3. But here it is clear that the 1/2, the square root applies to the negative and the 9. So here this is the square root of -9, which is no solution. No solution, we have to specify an R. Now, last example for today. If you have 9 to the power of 3 over 7 times 3 to the power of 1 over 7. In this case, we cannot apply the rule a to the power of m times a to the power of n is equal to a to the power of m plus n because the bases are not identical. We have 9 and a 3. But if there was some way I can get rid of the 9, make it a 3 or the 3, 9, that would work. The easiest way to do that is to make the 3, write the 9 in terms of 3. So 9 is 3 squared, right? So instead of writing 9, we're at 3 squared to the power of 3 over 7. We just changed the 9 to 3 squared times 3 to the power of 1 over 7. So here, we can apply the rule of the power rule, where is it, right here, and multiply the exponents together. So this becomes 3 to the power of 6 over 7 times 3 to the power of 1 over 7. Now, since the bases are identical, we can apply the multiplication rule. This becomes 3 to the power of 6 over 7 plus 1 over 7, which is equal to 3 to the power of 7 over 7, 3 to the power of 1, or simply put, 3. So I hope that this video was helpful, and if you have any questions, please write them in the comments section. And if you like this video and you'd like to see more math videos like this, subscribe and like the page. Thank you. Bye.